Welcome to Biology Made Easy. Biology Made Easy are biology lessons planned, designed for biology students in high school and secondary school. Students will find the lessons great to propel you forward. Welcome. In our last lesson, we looked at biological techniques. We discussed specimen, sectioning, symmetry, orientation. Looked at what they are, how they can be done, and the importance of these. And today we are looking at biological drawings. We'll look at the skills, all right, to make very good drawings. Good. Now, quickly, what are the tools you need? What do you need to do biological drawings? You've been drawing in biology. Just list some of the tools you've been using. Good. Now, what do you consider when doing biological drawings? What are the things to consider to do very good biological drawings? One of the things to take note is the orientation. All right? The orientation must be correct. You cannot draw a human being upside down. The orientation will be wrong, bad. And then also, you can be asked to draw, for instance, the dorsal view of a cockroach, or the ventral view of a cockroach, and that you need to know what a dorsal view is and what a ventral view is. So you need to know the orientation. Then another thing that is needed is proportions. Your proportions must be good, right? And we are going to use that leaf in the short to look at proportions and some of the other things that you need to look at during biological drawings. So let's go. Well, I managed to draw the leaf and the short. I managed to put this leaf down as this. All right. And we are going to use this to describe the do's and the don'ts, the good and the bad. So first of all, we want to look at proportions. Look at the leaf in the shorts and look at the one that I tried to make. If you drew the leaf like this, the proportion is wrong, because the leaf in the shorts, this side of the lamina is smaller than here, so the proportions of your drawing is bad here. This is bigger than this. In actual fact, this part should be smaller. So the proportion is wrong, bad. The proportion is not good here. The two are almost the same, all right? And look at the size of the petiole here. So it makes the proportions wrong. The petiole is too big. So take note of the proportions of your drawings. They are marked. They are looked at. Good. So beside the proportions of the drawings, we want to look at what is called the outline of the drawing. Now, the outline of the drawing is how neat the drawing goes. Very neat. That's a neat outline. Like this one, neat. That's the outline. The outline should not get bushy. Should not be bushy. It should also not get breaks. For instance, I don't have a neat outline like this, and I have it's bushy, or I have breaks. is wrong, because this sticking out here in biology can mean something else. It can mean a hair or a cilia stuck in there, sitting. So the outline must not be bushy, because this structure may mean something else. And if there's a gap here, it can also mean that the structure has a gap. There's a gap here. It means that's how the structure is, with a gap. We also want to see guidelines. The guidelines are the lines that are leading to structures. The lines that are leading to structures. If I have a structure like this, and I'm showing a structure in here, this one is I rule a line here. It's showing my structure. This is a guideline. This guideline must not be ruled with my hand, free hand. All right? Free hand is not allowed. It should always be ruled. The guideline must also not be used, arrows used. So you use an arrow as a guideline, it's not right. Then the guideline should, I want to touch this structure. The guideline must touch the structure. The guideline should not just be hanging in space, all right? Not really touch the structure. The guideline must touch the structure. If the guideline doesn't touch the structure, you don't get. And then the guidelines must not cross each other. So I have this structure here. I have another structure. Let me make it a new one. I have this structure here. I have another structure here. And I'm doing guidelines. And I do this guideline here. And I label it. And I do another guideline here. And I do another guideline here. And I put down my label. And these two guys, I said this is an eye. And this is nose. And these guidelines are crossing. The guidelines must not cross. No guidelines must cross. So it makes it wrong. The guidelines must not cross each other. And then if I'm labeling something which is a single structure must have a single guideline. So I'm labeling this structure, this as an eye. It should have a single guideline, and it should have eye. I should not label a single structure and say eyes. It's one structure. It should not have a double. If I'm labeling eyes, then I must have two guidelines to show eyes. So you don't use a single guideline and label plural. That isn't it. So guidelines, that's right. Now there's something called labels, and I've been using labels all the time. These are the things that I write to show are labels. So if this is an eye, all right, the label is here, eye. The label should not stand on the guideline, eye. No. The label should not be standing on the guideline. The label should also not be written on the drawing. No. All right? The label should be at the edge of the guideline, neat. The labels should also not be slanted. The labels should be neatly. Eye. The label should not slant and do like this. Eye. Slanted labels. No. Straight and neat. Now let's go to double lines in drawing. Anything that have thickness and then cut areas Anything that have thickness is represented by double lines. So the leaf we did, we'll look at it neatly there, but let's do this very fast one. This leaf we did has veins. Look at the leaf again in the picture. It has veins, and the veins have thickness even though they are tiny. So everything that have thickness is represented with double lines in biology. You see this is the midrib, it's thick. But you see the tiny veins, some is like this, some go like this. They are quite pronounced even though they are thin. So you don't use a single line. You give it a neat double lines. So anything that have thickness have double lines. And then cut ends has double lines. This end here, which was cut, should have a double line. Double line. So these ends should not be left loose. They should have double lines. Now, one thing I forgot to say is that you don't use arrows, you don't use these bracketed brackets. We are showing the leaf stalk. So this is the leaf stalk. No. Better rule a line, put them together neatly, all ruled. This is the leaf stalk. Every drawing has details that must not be overlooked. For instance, the leaf. If we are drawing this leaf, what are some of the details that we can't overlook? Look at the shape of the leaf. It's a detail, isn't it? Look at this part of the lamina. This is a detail you can't miss. The shape and this you can't miss as details. Now, still on detail, let's look at this fish and use this fish to look at our detail. You are drawing the head region. One of the details that you shouldn't miss is the eye. Look at the eye. You can't miss the eye, the way the eye looks like, the eye. All right? It's a detail that you cannot miss, period. So look out for important things on your drawing and put them in. Now let's look at headings of drawings. Every drawing needs to have a heading. You can't draw without heading. This fish, the heading is drawing of the lateral view of the fish, bony fish. If you know the name, you put on the name. Scientific name, well underlined or italicized. So the headings are very important. If you are drawing the orange fruits, all right, you have in the short, is drawing of the transverse section of orange fruits. All right, you have the mammalian heart there. Drawing it, the heading is the diagram of the longitudinal section of mammalian hearts. Now note in the headings the following: the name of the specimen, if you know the scientific names, should be underlined properly or in italics. The view, the anterior or lateral, etc., is necessary to quote in your heading. Then the type of section, whether it's longitudinal or transverse, you need to quote if the specimen is cut. So therefore, Lastly, we want to look at magnification of your drawings. Every drawing must have a magnification. Every drawing must have a magnification. And this is how you work out the magnification. Let's look at this. For instance, you've been asked to draw this leaf. Your drawing should be between 10 and 12 centimeters long. Let me use this board to try to explain. It would also be good on paper, but let's imagine that this whole board is our paper. Now, how do you work your magnification into your drawing? All right. So on your sheet of paper, you take your ruler and you mark quietly small somewhere. 12 centimeters is here. 10 centimeters is here. You mark small because with pencil. You mark with pencil small. You erase it later. So the leaf you've drawn should fit into the space. Then you are in the space between 10 and 12 centimeters. All right? Good. So you've done all your labeling and everything correct. Clean off the marks you did to show, to be able to be in between the length you've been given. You clean it off. But then you have to measure the length you did. This length is 11.5. You've been given the leaf to draw, so you measure the leaf length. You measure the leaf length, and the leaf length is 6.5 centimeters. On my drawing, I have to put on the magnification. This is how we work the magnification. Magnification of your drawing, length of drawing divided by length of object. That's how you work out the magnification. In this drawing, it's length of the leaf we have drawn, all right? And the object, the length of this leaf we have drawn, length of drawing. So in our work here, the length of drawing is 11.5 centimeters. All right? And the length of object is 6.5 centimeters. So when we divide that, we get 1.76. These centimeters and centimeters cancel out, okay? So we have 1.76. All right? So we round it off to 1.8. Now, so on our drawing, the magnification, we just write somewhere here, times 1.8. That's how we write magnification. All right? So you do your everything correct. The labels, the detail, the heading, everything is written. Then you write all your things nicely. You give your heading, and then you put your magnification times something. Excellent. The assignment is state 4 importance of biological drawings. Well, this is what we have for today. In our next lesson, we will still look at biological techniques. We will look at microscopes. We'll look at hand lenses and microscope, how to use hand lenses and how to use microscopes, how to keep microscopes, maintain microscopes as well. Well, thank you for today and bye-bye.